Let's think about your body for a second. Not as a single thing, but as this incredible collection of trillions of tiny, powerful engines, all firing at once. Today, we're going to pop the hood and ask a really important question. Are we actually giving these engines the right fuel to run their best?
And this really is the key question, isn't it? Because just like any engine, if the fuel is wrong, things start to sputter. So let's figure out what the right fuel is, all the way down at the cellular level.
You know, to really understand the fuel, we first have to get to know the engine. And every single thing your body does, from thinking a thought to lifting your arm, it all starts with the health of your individual cells.
Just look at that number, 70 trillion. That's the estimated number of cells that make you, well, you. It's mind-boggling, really. Every single one of those cells is its own little unit that has to work perfectly for you to feel your best. It's literally an entire universe inside of you. And it really all boils down to this super simple concept. Get the good stuff in and get the bad stuff out. This basic exchange is the absolute bedrock of health for every cell, and it's all controlled by one critical part.
So what is this good stuff our cells are trying to let in? Well, the answer might actually surprise you. We've spent decades being told that fat is the enemy, but it turns out our cells are literally built out of it. We just need the right kind of fats.
So let's meet the heroes of this story, lipids and sterols. These are the good fats we're talking about. They're essential because they make up most of the membrane that surrounds every single one of your cells. The source material points out that these fats are what give the cell membrane its flexibility, its pliability, which is crucial for it to work right. And this is the perfect way to think about it. That membrane isn't just a wall, it's a super intelligent gatekeeper. The source material says it has discretionary power, meaning it gets to decide exactly which nutrients get a VIP pass to come inside and which waste products get kicked out.
Okay, so where do we find these critical building blocks? Well, the research points us to whole foods like these. The key lipids and sterols that our cells are craving are packed into parts of these specific grains and legumes.
Now, if these nutrients are in grains, we should be all good, right? Well, this is where our story takes a pretty sharp turn. We're going from the microscopic need for these fats to a huge problem in our modern food supply.
And here's the crucial point. All the good stuff, we're talking vitamins, minerals, and especially those lipids and sterols, it isn't in the fluffy white starchy part of the grain. It's all concentrated in the outer layers, the bran and the germ. This slide lays it out perfectly. The modern milling and refining process is literally designed to strip away those nutrient-dense outer layers. So we're left with things like white flour and white rice, which are missing the very ingredients that made the original grain so valuable.
So we have to ask, why on earth would we do this? Well, there's a simple reason: shelf life. See, by removing those fatty outer layers, the grain can sit on a shelf for much, much longer without going bad. We basically made a trade. We gained convenience, but we lost a huge piece of our cellular nutrition in the process.
Okay, so let's connect those two ideas. We've got this big problem in our food system. What does that actually mean for those 70 trillion tiny engines inside of us? What are the real consequences?
Wow, this comparison says it all, doesn't it? On the left, you've got a cell with a membrane built from lots of good fats. It's flexible, it's efficient. The bouncer is on top of its game. But on the right, without those fats, the membrane gets hard and rigid. The gate just doesn't work right, and you get a serious cellular traffic jam. The source material uses this language, and it's pretty graphic, but it is spot on. A deficient cell can be starved because it can't pull in the nutrients it needs, even if they're floating right outside. At the same time, it can become constipated. It can't get rid of its own waste. That cell is now struggling, just trying to survive.
So that all sounds pretty bad, right? But here's the good news. If the problem is a lack of these lipids and sterols, what does the science say about putting them back in? How can we refuel our engines?
This is where it gets really cool. A study in the journal PLOS One took a look at rice bran, one of those sources we mentioned, and what they found was that its oil helps calm down inflammation by improving something called mitochondrial respiration. That's basically a fancy way of saying it helps your cell's little power plants, the mitochondria, breathe and create energy more effectively.
So let's just connect those dots. When your mitochondria can breathe better, it's like giving your cellular engines a professional tune-up. They get way more efficient at turning the food you eat into pure energy. The study showed this was a huge deal for immune cells, helping to reduce inflammation. It's simple, really. Better energy production means better working cells. Okay, so let's wrap this all up. What's the main takeaway here? Well, first, we're really only as healthy as our cells are. Second, those cell membranes, the bouncers, they absolutely need those good fats, lipids, and sterols to do their jobs. Third, modern food processing often strips them away, which can lead to tired, inefficient cells. But finally, and this is the hopeful part, the science shows that when we put these nutrients back, we can help refuel those cellular engines for better energy and better health.
And that really leaves us with one last thought. We've taken a look under the hood, we've seen how the engine works, so now the question isn't just what should I eat, it's a much more powerful question. How am I going to choose to fuel my cells? And that's a pretty amazing choice to have.